Hello, Honors Pre-Calculus students. It's Mrs. Homan here. Welcome to your first online learning video. Ms. Cronky and I have decided that we're going to go ahead and start with Chapter 10. I know that we were working on Chapter 6 when spring break started, but we're going to go ahead and say we're done with Chapter 6 and we're going to move on to Chapter 10. So in Chapter 10, we kind of break it up into two parts. Chapter 10a is all about conic sections, which we'll get into here in our next lesson. But before we get into what conic sections are, we need to review a skill that we learned at the beginning of this school year called completing the square. So this video, I'm going to take you through some examples and remind you what we talked about back in Chapter 2 when we completed the square with our quadratic equations. Okay. So I'm going to go ahead and get my whiteboard up here. And we'll go through some examples, okay? So first of all, I want to talk about this quadratic right here. X squared plus 8x plus 16 is what we call a perfect square trinomial. We call it a perfect square trinomial because we can factor it perfectly, okay? So 16 is a perfect square, and if we take x squared plus 8x plus 16, we know that that factors to x plus 4, the quantity squared, which we like to call the square of a binomial. I wouldn't say that those terminologies are super important for you to know, okay? But this is why it works the way that it does. So I'm gonna go ahead and erase this right here. We have a pattern, okay, that anytime we have a perfect square trinomial, it is in the form of x squared plus bx plus, there we go, b over 2 the quantity squared, okay? So in our example, 8 was our b value. If we take b and cut it in half, b over 2, and then we square it, we get 16, okay? So it follows that pattern. Every perfect square trinomial, what I have over here in blue, will factor perfectly, and typically you'll just be able to see it, but I'll tell you ahead of time that the pattern is always going to be x plus b over 2, the quantity squared, okay? Now, what I wrote in blue isn't necessarily a huge deal for you to remember that that's the pattern. What is a big deal for you to remember is this b over 2, the quantity squared. Okay, we are going to force that to happen with our completing the square. So what we're going to do is we're going to go through, it looks like 3 examples. So back in Chapter 2, we had some quadratics. Let's say we have y equals x squared plus 6x minus 3. Okay, now we know right now that this can't factor. Okay, there is nothing that multiplies to -3 and adds to +6. Okay, so we're going to deploy our strategy of completing the square to force a portion of this to be able to factor. Okay, we did this when we wanted our parabolas to be in a standard form that we talked about in Chapter 2. So our strategy was to go ahead and write out our problem, but we left in blanks. We were going to add a mystery number, and we can't just add in a number. That doesn't make sense. So if we're going to add a number, we could either add the same number to both sides, or we can subtract the number from the same side. Okay, so here's our b value, 6. If we take b over 2 and square it, so right here, b over 2, square it, b over 2 would give us 3, squared would give us 9. So we're going to add 9 and subtract 9. Okay. Well, then what can happen is we now have a nice perfect square trinomial. So what I'm circling here in yellow, that's a perfect square trinomial that we can factor. We know that x squared plus 6x plus 9 would factor to x plus 3, the quantity squared. And then we can just out here, negative 3 minus 9, we can just write as minus 12 after the fact. So we have rewritten this quadratic into standard form by completing the square. Okay. Okay. Now, our strategy that we just talked about only works when our leading coefficient is 1. Okay, so our leading coefficient, I'm going to underline here in green. X squared was our first term, so our leading coefficient was 1 in this case. All right, well, what happens, how does this get affected if our leading coefficient is not 1? Okay, so in this example, we have y equals 2x squared plus 8x minus 1. We do not have a leading coefficient of 1. So what we have to do is we have to factor it out. Now, since 2 is our leading coefficient, I'm going to write it, and we're going to factor it out of anything with an x. So it's going to get factored out of our x squared term. It's also going to get factored out of our x term. Okay? We know that we're going to need a mystery number. I'm going to close the parentheses. I do not want to factor 2 out of 1. It's not going to be fun, first of all, and it doesn't matter. Okay, so that minus 1 is going to stay after the parentheses. Okay, I only factored the leading coefficient out of any term with an x, and then the minus 1 is after the fact. So we're going to add our mystery number in the parentheses, and we're going to balance our equation by also subtracting at the end. Okay, so here's our b value, 4. b over 2 squared would then give us, well, b over 2 would be 2, squared would be 4. Okay, now here's where we have to be careful. Okay, technically, yes, we wrote 4 in our equation for our mystery number, but this 4 is being multiplied to this 2 that we factored out. So to balance out our equation, we actually have 4 times 2. Okay, so that number is going to be 8. Okay, so when we go ahead and rewrite this, we have the 2 that we factored out, our perfect square trinomial, x squared plus 4x plus 4 is going to factor to x plus 2, the quantity squared, and then we have minus 1 minus 8 for minus 9. And there is the standard form of our quadratic. Okay, it is important that we get that leading coefficient factored out of the x terms so that our completing the square will work. Okay, so we're going to go ahead and do one more example where our leading coefficient is not 1, and then you'll see that our assignment has a couple problems already done for you, and you'll just need to fill in the rest. Okay. Okay, so our last example, we're going to have negative 3x squared plus 6x plus 7. So our leading coefficient is not 1, it's negative 3, so we're going to have to factor it out. Okay, when I factor negative 3 out of our terms, we are going to be left with x squared minus 2x. I'm going to leave room for my mystery number. Notice how I've closed the parentheses, and then I'm going to keep plus 7 outside the parentheses. I'm not going to factor it out. Okay, I only factored out of our x terms, and by closing the parentheses, that 7 is not affected. Okay, so we're going to add in and subtract our mystery number. Okay, our b value is -2. -2 divided by 2 would be -1. -1 squared would be 1. Okay, now be careful because we wrote 1, but we're really not adding 1. Okay, this 1 is being multiplied to our leading coefficient of -3. So what we are really adding is -3 times 1. Okay. So now we can leave our -3 factored out. X squared minus 2x plus 1 will factor to x minus 1, the quantity squared. And then we have plus 10. Okay. So now you have some problems to do for us. And remember, Miss Cronky and I both have our Zoom sessions to where you can pop in and ask questions as needed.